So my name is Stefany Allaire. I'm the designer and creator of the C256 Foenix, which is today it's more like a line of products than just one single thing. And before we get into the nitty gritty of everything I want to talk about today, I'll go through my agenda and then I can start talking about more about myself and my background and what did I do to get here today and, stuff like this. So today I'm going to, like I said, I'm going to talk a little bit more about my background because in the previous years, I didn't do much of that. And I think it's important to know where I got my skills. Next, I'd like to go back to a slide I created last year which was really all the things that were designed for the last 4 years. And by the way, it's like the 18th of April was the 4th year I got involved in this. So I've done a lot. We've done a lot. The community did a lot as well. And I want to spend some time on my philosophy, why I'm doing this, what's the vision of this, why I'm kind of going against the current about, the retro world today is very, driven by, going, you go in your cupboard or your whatever, you get your old computer, you're cleaning it up and you're pipping it up and then you make it work. And then that's, at least from my perspective, that's about it. For me, it means more than that. So that's why I got into what I'm doing today. Then I'll go and jump into the new product that will soon be out. And I mean, the whole idea of the Gen X started last year, but it took like a whole year to really get it done and finished and, really ready to go. So I'll show you the boards and the features, the possibilities. So it's a bit more marketing talk, really to get you interested in it. Then the different possibilities of it, the different processor boards, because it's meant to be very flexible, the A2560X, and why, if you go check on the website and the store, you'll see why it's so expensive. But the question is it that expensive considering what's involved to actually create these things? Then I'll touch on the future, what is going to happen in the future, and the questions, if anybody have any. All right, so I hope I'll make it smooth sailing for you. I'll try to not read my slides. Basically, my career, I mean, the whole story began when my father bought a C64, which is kind of ironic because today was like the big Commodore day. But yeah, my interest in computers and electronics in general, I started like back in 1982. And because my father bought a Commodore 64, I've been, after like studying all the different models at the time, which were not that many, but still. And he ended up paying the full price. And I'm living in Canada. I'm French Canadian, by the way, so I have an accent. But he did pay the full $1,000 Canadian the first year, and we had to wait to get it. And then the funny part is that it sat there for a while because, at the beginning, when it really was released, there was really nothing for it. And it took a while for it to get some interest and development made. And that's pretty much where we are right now with the Foenix projects. But anyway. But then I got interested and I started playing with my brother's Radio Shack lab kit, with the wires, with the little springs and everything. And that's really got me into it. To get more deeply into this, and I got interested, and then games start pouring in, and I started hacking those games, getting removing the protection, and this is really where the whole interest got. And for some reason, I was always very interested in the graphical aspect of things, 3D graphics and 2D graphics, and anything that is related to a pixel. And then I got into electronic, went to the college, got my degree, and then started my career. But I was really driven at the time. I had a lot of, very motivated, and I was an entrepreneur at heart, but not a lot of experience. I got backstabbed a couple of times by the people I was doing business with, but still, I've learned a lot. And so I basically went from starting my career, got a lot of experience, and then I started my first company. And the time was the time of where the first 3D rendering cards were coming out, and I wanted to do more. I was interested in VR, and you see VR it seems for the millennials that VR is a new thing, but it's not a new thing. I mean, VR was there like 1990s, not like it is today, of course. but still, it was there nonetheless. And the idea was to sell a product where we would accelerate the, the geometry processing, basically what the GPUs do today. And but back in the days, I was using DSPs and I was using 3D rendering chips that existed at the time. So that didn't work. And then I went to do some sales, and then the company went bankrupt. I bought the company back. I tried to do it again, but it was too late. Then I moved on to do something else. Went to sales again, and I've done a lot of hardware design. And then I would say that in 2004, I eventually went back to start my own company. At the beginning, it was mainly about post-processing for, image generated for the movie industry. It was taking a lot of time to do the rendering at the end. So I wanted to create like a parallel processing stuff, and that's what I designed at first. But the adoption was difficult, and I saw a lot of potential in LA for the movie industry. So I moved there, but I moved there in 2008. And 2008 was really the crash. And basically my technology was around a chip from a company that was called Brick at the time. And basically the company went belly up 2 months after I moved there. So I ended up with no product and a lot of money spent. So I had to reinvent myself over there because I was not going to come back. It took so much energy to just go there. So I basically started designing global shutter cameras. So you see again, imagery, pixels, and I started doing a lot of camera designs. But the business part of things is that I love to design products. I'm very good about creating products, envisioning them, designing them, but selling them is a different story. I hate it because, you kind of have to lie, and you need to get people out of their own way. And I'm not very good at this. So I kind of let it go at some point. I came back and start working for other companies and, being a slave to others and use my talent for others. And then in 2018, I kind of went back into, I think there was a good year for retro, people going back in retro. And then David Murray, the 8-bit guy, did his thing about, I'd like somebody to design the retro computers. And I did because I felt like I needed a new challenge, and I got into it. And that's what basically brought me in the whole retro world. So I wrote something at the end of the slide, which means meaning that basically I became, because when I was in LA, when everything went down, I had to construct new skills. So I started doing FPGA design and mechanical design, and I kind of completed the whole spread of talent I could use to create products on my own. And that all those failures really taught me a lot. And then nobody should be afraid of failing at doing something. Maybe one day you'll succeed and you'll be like, okay, I'm done. I'll move on to something else, right? But yeah, so in the end, failing is a good thing, and we learn a lot. And today, that's what gave me what was necessary to create what I've created so far. So these are ultimately all the products that were designed that I designed since I got involved. So the first, so at the top here, the C256 Foenix Rev A was the computer I created at the very beginning. That was the closest to what David wanted from his wish list, although it was definitely something that was, because my idea was, if I'm going to shed all the money and I'm going to do it on my own, might as well create it in a way where it's going to be more my take on what David wants, as opposed to what specifically David wanted. For example, David was kind of not keen on the FPGA, using the FPGAs and everything. And I was like, no. I think it's important to have FPGAs because I consider them like the ASIC of the Commodore world and everything. So we need to have like glue logic integrated, not put everything like a Mr. board or anything, but really trying to get a feel of what it's like to have a computer. So that was the mission I gave myself at the beginning, was just like, I'm not going to pluck just a FPGA in the middle of the board and just say, okay, this is what my computer will be, and I'll just integrate everything. I stayed away from that concept because for me, it's like, okay, otherwise I'm just creating a Mr. board. There's no point to do any of that. So it's about really creating the feel, the when you play with it, when you look at it, it was really the purpose. So the Revision 8 never saw saw my lab. That's about it. Never went anywhere else. Then the Rev B2 came. I got some people interested. I made 5. I sold them, and we started with that. And then from there, the community grew, and Then the FMX came. The FMX was really a fixed version of the Rev B2, but with a lot of sound chips, thinking that, oh, if I put all these chips in there, I'll have a lot more people interested. But, you know, surprisingly, that didn't work out very well. So the whole chip sound chip like the Yamaha, we'll come back to them later. But essentially, the FMX was like a lot of sound chip all together. And for anybody who's, you know these things would be like, oh my God, this is so great. But that's the problem. People wanting these chips don't necessarily do programming. They don't want to, you know, start programming something from something they don't know. And I still sold a lot, 70 units. I mean, for me, it's a lot, okay, because I kept doing stuff in the niche market. And the more I went, the more I stayed, and the more I kind of put myself in the corner and say, this is where I want to go. Because at the time, at least, the Commodore, not the Commodore, but the Commander X16 was coming out, and there was a lot of a big following, and the Mega 65, they have a big following. So both were playing the 8-bit world. And was like, okay, I don't have their audiences. I don't have the attention they got over the years. So I said, okay, might as well find my niche, find my place where I'll do something that the others don't do. So slowly, in between, before I got to the Gen X idea, I tried to do something low cost, because, you know, people were like, okay, it's too expensive. But in reality, and after a while, I realized that it was never about the price. It was really about, this is not talking to you. It's like, it's not, it doesn't resonate with you. It's not, because if you want something, if you're really attracted to something, you'll spend all the money in the world. It doesn't matter. So it was not about money. It's about value. What people didn't value it because it was like a black box. They didn't know it. They didn't want to get involved with it. And we'll come back to that in my philosophy part of the video. So I created these two units, but by the time I created those two low-cost version, which are the U's, which are great for people it's an entry-level boards. They're great, but then the FPGA pricing starts to go up, just making the whole project, you know, not very affordable. So the whole idea that the FPGA that we would buy like $25 a year ago now sells for $200. It's like, okay, these products don't make sense anymore. So that also kind of forced me to go into more expensive stuff. But the more expensive stuff brought me into the world where, okay, only certain individual will be interested to spend that kind of money to play with a computer of their childhood that would look like their childhood. So the Gen X was thought last year, was brained, and then I came up with the idea, and then I made a video about it, and it looked different back in the day because it was just a concept. And since it was so complex, I thought, okay, let's create like a development board. And the development board ended up being the A2560K because I wanted to do a model with a keyboard. And eventually the K was the test bench, if you will, for me to do the development and to debug the boards and find all the problems and test different things. And ultimately by the, early this year, I finally finalized the design, started to produce it, but then these are very complex. They have a lot of components and they're very, not difficult, but they are complex to build. They take a lot of time to build. And that's another reason why I wanted to go on more expensive stuff, because this is not something I can go and send to China and say, hey, make 20,000 of these guys. This is not going to happen. So it's still very much artisanal in nature. But the K, it was the development board that made the Gen X happen. And back in February, the idea was to buy a pick and place, which I did. And we're in April and I still don't get it because it's still in customs. So for the last 2 months, the pick and place has been living in the customs somewhere in Ontario. And which is, on one hand, I think it's a great thing because it allowed me to actually get on finishing the Gen X, which I did. And hopefully it'll come in sooner than later, which will allow me to produce these things a lot faster. But anyway, so throughout the development of the Gen X, I came up with the ideas that to do different different sizes with different features to kind of give a more broad offering for pricing. So at the end of the day, there's 3 live product today, which is the A2560K, which is based on the 68040V that we announced last year in October here. And there is the two Gen X. Actually, there's the Gen X, which is the dual processor, the 65, 816, and a module, 32-bit modules you can insert in, and the A2560X is only the 32-bit modules, which is comparable to the A2560K, but there's no keyboard, of course. So this is the lineup, but ultimately, this is why I put this little purple line in between. This section is really where we are at today. So they are more expensive, but there are more stuff in there. There's definitely more feature. There's definitely a lot more to play with over time. And eventually, if the FPGA goes down, we could reintroduce these entry-level products. All right, let's do a little bit of philosophy. I'll try to make it quick. Ultimately, the way I see the retro community, when I got into it, was really, okay, I see all these people, like I said, getting their stuff out of their cupboard basements and everything, and dusting them off and try to make them work, cleaning them up, and doing some retro brighting and all these things, and updating everything. And but I realized after a while that then you start playing with your old games and everything, and I figured that there's only so much time you're going to play a Commando, right? This is like when you get everything, the fun of doing this is really to do the work of putting it back together. But when it comes to play, I'm not sure people are playing that much. Because you've played all these games when you were young, so when you're going back to it, it's like, okay, I've played that game, it's fun, okay, let's move on, let's get something else. So that's why I'm saying there's nostalgia that from most of the retro community right now is very fleeting. It's part of because for me, nostalgia was super important, because the world we're living in right now is pretty shitty. There's nowhere to go really to have fun and to feel good. So I thought that the retro, going back in retro and going back in time was great, but something was missing. And that's what I've been pushing for, is that ultimately, I think, this is my opinion, by the way, so I'm not saying that people pipping in their stuff is not a good way to have fun. I'm just saying that I think there was something missing. And I think the part that was missing is the aspect of actually sitting down in front of something we didn't know anything about, and doing the work to understand what it was and try to make it work the way we thought it would work, and then start to getting to know it, and to the point where today, we know everything about a C64. There's nothing else to know. There's nothing else to know about an Amiga and all those retro computers. We know everything there is to know about it. So it's kind of, we reached this dead end, and we ended up being in this world of, we're so complacent. We just don't, we're so indoctrinated in our ways of seeing things, doing things. And I can see that in people playing with the retro computers, because they're trying to bring 2022 technology into 1990s computers. So we've been so much indoctrinated by the dark ages of the PC and all these things, that it's very difficult to get out of this comfortable place we are. Like, okay, we can find a C compiler really easily. We can do things so easily today. So going back to this, it's difficult to let go of these ways. But for me, the philosophy is that, how about we go from scratch and we reinvent new ways? That's the idea, right? But it requires work. And right now I'm trying to sell the idea that you should spend $1,000 to do work. And people don't respond very well to that message, but because they're missing the point. Because at some point along the way, after the work, there's the pride, and there's something that you can only live and feel if you actually do the work. And anybody who's creative a little bit knows exactly what I'm talking about. All these hours of procrastination and failure, but eventually it will work. And the day it is working, then you feel very, very well. And that's what I'm talking about. And even if you spend $1,000 for it, you don't care, because you actually got something much more rewarding than just, putting your casing in, outside for it to become, wider and stuff like that. So I'm sure people understand what I'm trying to say. But another aspect of what we're living through right now is the idea that the attention span of people is very short. And so even today, I see it in the community. I see people so excited to get the machine, and then all of a sudden, whoops, they go away, they don't come back. I've seen that over and over and over again. So they got it, they paid for it, but they're like, ugh, I know, it's too hard. But anyway, so there's nothing you can do. This is human nature. So this is really the philosophy. So that's what I'm pushing. I'm really going against the current. It's tough because, you know, I'm not sexy, I'm not popular, I'm not trying to sell you or getting out of your way to buy something for the money. I don't do that for the money. It's really about giving the tools for people to kind of find some pride again, to find some love of doing something they really, and it does bring people back in this time and they feel really good. So I can tell you that. So most people who actually put the work into this really felt like, and I got a lot of emails like, wow, this is so cool that I really feel it. And that's what I'm trying to share with the world. But, you know, I'm going against the current. So it's kind of normal that I get that you know, reaction, I suppose. So, so basically the Foenix new retro computers are about work, restriction, possibilities, and pride. So it's really about this tool that gives you this thing. But it's like, if you're going to the gym, if you want to lose weight, you need to do the work, and then you're proud of you and everything. And then you can gain the, you know, the weight back, and you do it all over again. And that's the thing. It's not about making money. It's not about fame. It's not about being popular on YouTube. It's not, you know, because some of these people are involved in that kind of stuff. But man, there's no ego. It's really about, let's share stuff. And I'm pretty proud of what we've created together with the community, because we have a great community on Discord if you want to join. It's people helping each other, and we're really going somewhere, but it takes time because people have lives and there's no incentive for them to just stick to it forever, because again, there's nothing to pay for their rent. So they're not going to stick if they cannot do that. But it's freeing. And the other aspect that it's really freeing in a way, because we're so caught up, for anybody who's doing software development or anything like that, you're caught up into this world of everything is given to you. You have 20 layers of virtualization in your computers. There's no access to the hardware at all. There's no control over anything. You're a slave to what's been given to you. So the new retro computers gives you this chance to go back to, if you write to register, it does affect the machine right away, and you can do that. For me, that was very important, because I'm so tired to deal with these libraries that I have no clue what's going on. So this is another aspect. So you have a lot of graphics, a lot of sounds, a lot of memory you can store, and it's you and the machine, and you do whatever you want, and nobody's going to tell you, oh, you have to use this, because otherwise it's not going to work. The potential of the community is based on what people want to do and will be capable to do, and you have everything to do it. So again, no pain, no gain. All right, so that ends my program for the philosophy. Hopefully you're not sleeping. All right, so let's get into this. So the Gen X computer was really to honor the Gen X generation, which is really the hardworking, and because we're sandwiched between these two lazy, entitled, no offense to the millennials in the crowd, but you know, we worked hard, and you know, that was the generation we could go outside and nobody cared. But ultimately the Gen X is this platform that has dual CPU. I'll show you how it works. And I created 3 flavors, 3 sizes. And it's funny because when I created those, I never thought that there was actually a naming scheme for these type of sizes of computer. I just created them because it made sense for me. But apparently there's these Spark stations that were called Lunchbox, and they're about the same size. Obviously the cube is really, so basically this is the cube, this is the Lunchbox, this is the pizza box. But yeah, so I just created them like this. I didn't know about these things. Just later that people, oh, and yeah, their Spark station was about that size. So that was kind of funny, but I've been trying to get into that world of like more CGI-ish type computer and next computer and more high-end stuff, you know, to justify the price and justify the, you know, the spending. And maybe you don't have to fight so much with your wife to get the money to do it. All right, so for a long time, that board was just a dream, but now it does exist. So it really is a kind of a replica to a certain degree of a 2560K, but more integrated. And there's a few more things that the K doesn't have. Obviously, there's no keyboard, internal keyboards. But if I go from the corner here, and I'll go around. So we still have the Super IO that gives you 2 serial ports, official PC compatible serial ports. You have the parallel ports, you have the 2 MIDI ports, and you have the floppy, and you have the PS2 in front for the mouse and keyboard. Then the K came with the dual head video controller. I talked about VK2. But it's more VK3 in the K and the X and Gen X. It's really a dual head with a text side, mostly text to debug and to do different things. They'll have a little bit of graphics, but not much, just enough to use it for game or stuff like this. The other one is really more graphic oriented to do different resolution, like the 640 by 480, but then you have all the double pixel modes where you can do 320 by 200. Everything is 1 byte per pixel with lookup tables. So there's no fancy RGBA or stuff like this. So it's really 256 color, but you can have access to 8 lookup tables. So that extends it to 2000 colors, but out of a 24-bit palette. So then you have the network compatibility and connectivity that so far nobody's using, but I'm sure eventually will come. There's 64 megs of SD-RAM. There's always the 44 pins, 2.5-inch ID port that's been on most products since the very beginning. There's the 4 Atari style joysticks that with 2-3 buttons. 2 of them can be switched to do analog inputs. And there's an adapter you'll see on the enclosure that you can do SNES and NES at the same time. So here in the center on the left, we have the 65816 subsystem. So this is the CPU block number 1. The reason the Gen X has that is because most of the product we designed in the beginning were based on the 816. And when I thought about doing something with the 32-bit processor, I thought, you know what, I don't want to dump everything we've done so far. I think we need to build on it and keep going with it. So that's why I thought, okay, let's try to do something where we could switch from one to the other. Although not everybody would necessarily want to have both. So that's why the Gen X comes with the socket to put 32-bit modules, but they don't necessarily come with a module. So you need to buy the module separately. Then we get into the audio section. In this case, it's like in between the 32-bit sockets. So we have the 2 SIDs, the 2 external SIDs that they're not provided, but the sockets are there. So stereo configuration, but you can change the jumpers to have different type of configuration if you want. On the other side, you have the typical FMX chipset, which is the OPM, which is the 2151, the OPM2, which is the OPN2, which is the 2612, and the PSG. These are in most model there, but the cheaper model don't have them, and the Pizza Box don't have the socket at all, because inside of the FPGA, we already have an FPGA version of all those chips. So you have 2 SIDs in the FPGA, you have soft cores for all these chips. But, you know, for the purist people that really want to have the real sound, you know, I kept these guys up. The OPL3, which is the audio chips that all the Gen X's, all the products have in common, is still there. The codec, there's the codec with the line in, line out, the headphones, and you have 2 DACs, one at 48 kilohertz and the other one at 44.1 kilohertz. So you can play back 2 different, speed rate at the same time. And finally, VK3, well, I call it more fat VK because it includes all the chipset in one. So you have the DRAM controller, DMA controller, and all the bells and whistles, sprite tiles, and bitmaps. So this is really, in a nutshell, what this thing is about. I hear people talking, but I don't hear them. Okay, so let's move on. So here, ultimately, you have the 32-bit module that I will talk a little bit later, but this is where you insert the modules where you can have different type of 32-bit processors. The idea was when I created this, or we thought about this, because I'm going to say we, because I've talked to many people on the Discord to come up with this, is to have a machine where there's a simple kernel in it, simple stuff, file system, nothing fancy, something that is open source, of course, for people to make it better if they want to, but something that is good enough so you can load files, store file, read your memory, store your memory, and run codes. And that's it. There's also in the front, which all computers, all the Foenix computer have, is I call it the Isp Debug Port, or the debug background mode, where you can download your code directly in memory and get the system reset and it's going to boot. So you can literally compile on your remote computer, get your stuff, download it, and execute it without doing the SD card thingy and blah blah blah. So all those computers, no matter what kind of CPUs there's on it, you'll have the same kernel. Okay, the deal is the interesting thing about the Gen X is you can change the processors, but the hardware around the processor is always the same. Okay, so if you put a 68,000, you'll have the same hardware. It's the same thing. That the address space for the different hardware might be placed somewhere else, different places in memory map. But ultimately, if you do some code in C and you put a library, you could put some if condition in there, depending where the base location of all those register level could be. But ultimately, the way you address these, the register block will be exactly the same. So no matter how and what it is, you'll always have the same hardwares, which is cool. So you can develop one software on the 68,000 and then, oh, you know what, I'll do it on the Intel DX2, and you just have to recompile it and it should work. So you can port through different processors. But the idea of having different processors is people have different tastes. You know, people love the Motorola, people love the Intel. So that was really to open up the door without getting into putting expansion slots and stuff like this, because, you know, people would have to design their stuff. And so far, my experience says that people are not really into the whole development thing for themselves, not at this point. Anyway, I don't think I need to go through the features. You kind of saw this. So the subsystem for the 68/816 comes with some flash, with some RAM. There's a maximum of 8 megs of RAM. You still have access to the 64. Well, I don't know about the 816, but the 64 megs of SD-RAM is mainly for the 32 processors system, but you still have the SRAM, which allows you to run your code in the SRAM and put most of your data in SD-RAM and use the internal DMA to move your stuff around for music and graphics and everything. Again, you have the graphics subsystem that has its own memory, which has 2 blocks of 32-bit and allows you to do a lot of stuff. And you have the dual DVI, like I said, the text mode and text and graphics. The sound, like I mentioned, there's the external chips, there's the internal chips. So even the pizza box will have all the sound chips, but in the FPGA version, the soft cores. The codec is still there, the 2 DACs are still there. The speaker is obviously not in the pizza box. Storage, SD card is always there. The 2.5 hard drive, sometimes it's included, sometimes it's not. And of course, the floppy is not in the pizza box and it's not into the lunchbox. As far as the rest, Atari DB are always there. For the pizza box, you can have an external box to have those access to the NES and SNES and everything else we've talked about. All right, so I'm going to move on. So the possibilities, what we can do, what's been done so far. So surprisingly enough, when I started doing this, I thought, okay, I'm going to put a lot of graphic, a lot of sound. I'm going to have a lot of people doing games and everything. And it's funny that I got a lot of people doing anything else than games, you know, OSs and utilities and languages. And I got a lot of these. So I'm showing up some stuff that are more pleasing to the eyes, but let it be known that there's a lot of people working on different utilities, languages and stuff right now, mostly. So what you see here are different games, but designed for the 60, the FMX and U's. So these will be compatible with the Gen X as well. So you have Space Invaders, Halloween, and Frogger and Race. And so somebody, John is working on this absolutely amazing MIDI controller with all the different chips. So when he has a machine, it's going to be pretty awesome software. So these games have been developed by 2 people only. There's many games in process right now, but again, like I said, life happens and people don't spend so much time, you know, so eventually there will be way more. There's a lot of work being done on different things. Some people are more cagey than others about showing their stuff when it's not done. On the other side, while the Gen X and the 82560K is very recent, but they're still planned. The OSF is definitely from Micah, is working on that, which is great. I'm working on my Jumpman for the 82560K. Utilities, people want eventually when to be able to compile on the machine, which makes sense. Immutas has been ported to it's in progress on the 82560U, so it's going to be, you know, easily portable to the 82560X and 2560K. And yeah, it's still, everything is very early for all the new products and everything. It takes a lot of time for people to get involved and do stuff. But we do have a great bunch of people very dedicated to what they're doing and very experienced, and they really have a lot of fun. I guess if they didn't have fun, they wouldn't be there. So So we're coming down to the modules now. So the way it works is that you have this, we'll have different types of modules like this, but right now we have only one where I made this general, this is a socket for 68040. And it's funny because at the beginning I was kind of worried about the 68040. I thought it was really tricky. And, you know, because I had so much pain with this 816, I said, never again. I will try not to have a lot of hubris with these things. I'll try to be very careful. So I started with the most complex, which I thought was most complex, which is the 68040, although I think the 60 is definitely more tricky. But anyway, so I created this socket, and since it's an FPGA, it's not difficult to migrate it to something else. So I created those modules here to have the 68 SEC00. So that's the first one I created. Then I did the 68040. The DX2 has been created, but I didn't have time to work on it yet. So all of these are, well, not just potentially, but will be eventually in socket form. And so there's a button in the front of the unit that you push on the button, you boot on the 816 side, and you push it again and you boot on your whatever processor is in the module at the time. And you can start doing your thing. So upcoming are these older version of the 68000. One of the reasons why they don't exist yet is because they're 5 volts. And those 5 volts are, those 5 volts require translators, and translators are a little bit more difficult to find nowadays, but also they're been tricky and I could have issues with them. So I tried to stay away from any potential problems. I did find a FE model that is very cheap because the 68040 at 25 is relatively cheap. There's a 40 megahertz that I'm looking forward to implement. I got parts, but I didn't have time, but it's like $500 a part because they're brand new and they're coming from Rochester, and that's the only place we can get them from. But the V33V, the FE33V is very cheap. So I'll probably make a module for that guy. I'll probably make another smaller one for the 68,000 because this is way too expensive. And ultimately, and if I ever get there, I'd like maybe to do a MIPS, which is the R4700V. And the RISC. I think the RISC-V will be amongst the things I will need to do really soon that will gain some priorities for maybe to get more acceptance in different types of markets. But that should be a soft core at that point. So there's no chip outside. It's going to be inside the FPGA. I'm always open to other ideas of processors. There's obviously a limitation, but the MIPS, for example, is kind of a funny one because of the bus is multiplexes and it's still a 64-bit. It's still possible because it's multiplexed. So that's why I'm saying that it could possibly be a processor that I could implement on the machine if I spend the time, and I had the time to actually do it, but a lot of production to be made before then. But, you know, so this is the way things would go with the modules. So it's pretty straightforward. Even at that point, there was an idea, maybe it's still a good idea to do an 8-bit module. So we could have like 3 sockets and you could pick and choose the one you want, like a 6502 and 6809. But the machine is quite expensive to get that kind of stuff. But some people are still interested to work with these processors. But then I would have to kind of tweak the core a lot to be able to let the processor have access to all the stuff. So it might be like a X16 at some point. So, so this is really ramping up. Where did I put my slide about the, oh yeah, so the 2560X, I think, oh, I kind of skipped on it. So the 2560S is the same board, but without the 816 circuitry. It's only for 32-bit processors. So when you get one, you need to buy the processors that, well, you need to upgrade to whatever processor you want. Same sizes, same features, stuff, but it's just a 32-bit processors. You don't bother with another switch to change. It's just one thing. You still can change the processor if you want with the modules, but there's no 816 in the model. So some people are interested in that, some are not. So everything that is 2560 is really always 32-bit. So different color scheme, a little bit like SGI back in the day. So yeah. Finally, why is it so expensive? Well, I'm sure you know that the world of parts, the supply chain is all, I'm not going to swear. I told Jeffrey I wouldn't swear. He's all broken.
All right.
I was going to say the F word. I'm not going to say it. Okay, so it's broken. The new kings have decided to break the whole economy and everything, so they could come up with their new monetary system. That seems to be the thing. It goes as it goes down as. I mean, it's going as far as I have so much problem getting my pick and place that is stuck in custom somewhere where for no reason whatsoever. It's just there. It sits there. Like you can feel that they're doing on purpose just to, again, I was going to swear, but I'm not going to do it.
Yeah, okay.
I'm going to be a good girl because I want your stuff to be, PG-13 and less. Anyway, so, all these computers are hand built so far until I get my PNP. It's all been placed by hand. The Gen X has more than 1,000 computers. Even the K has more than 1,000 components like capacitor, resistors, chips, and everything. Plus the time to print, assemble it and do everything, testing it. It's a lot of time. So yes, they are expensive. They are a piece of arts, literally. And so it's not going to be $200. But again, some people don't care about paying that money because it's about the value, what they're getting out of it. And I think some people really found a lot of value in them. So don't be surprised. Yeah, they are expensive and they're getting more expensive because, at some point I need to feed myself because the volume is not there. And one could argue that, it's like a vicious circle that if it was cheaper, I would sell more. But again, what stops this from being more popular is the fact that most people in retro community, at least in the retro community, is that most people are users. They're not developers. So my segment of the retro community it's that I could attract are people from the development world, people that are full-time developers, but they missed something back in their days and they would like to relive it or whatever. So going back to this is worth the money spent in it. So that means that the tranche I have in this pie is very, very tiny. So I will have to reconsider what I'm going to do with this. Anyway, so they're all handmade. It's very artisanal, but like I said, they're very uniquely made for you. They're custom for you. Even the K, you can pick the keys you want and stuff like this. So that's the good side about it. But the backs, the negative side, it's like it takes time. And when you don't get the machine you need to get things faster, people wait. But, nowadays we kind of used to wait. Even for a Kickstarter campaign, you would have to wait. And people have been waiting years to get their stuff. So I'm trying to not get people to wait, but really at this point, it's really out of my hand. And this custom thing is weird because it's like in the different dimension. It's like, there's no way you can talk to these people. There's no way you can do anything about it. Even DHL is not able to talk to them. It's like, no, we cannot talk to them. We have to let them do their things. And then all of a sudden they show and, oh, okay, we scanned it. It's fine. Anyway, let's move on. So yes, price of the parts, the availability in our case is more or less a problem. It's a problem of, demands and rarity. And, Chinese people have China has a lot of parts. Most of them are not that great, but they have parts. So that's the good news. The bad news is that they're greedy as FUCK. Okay. And I had to say it, but at least this one should pass.
Yeah.
Yeah, they're really greedy. Some of them are really, really greedy. I mean, we're talking about an FPGA I was buying like at $70, and now it's like $600. Like, come on. And the demand for it is not that great because people didn't overnight start to redesign their board to put specifically that part. So it's just about, they're rare, so we're gonna ask for more. So. But some of them want to sell, so some are not that much more expensive. But again, quality is sometimes a problem. But anyway, this is the least of our problem because most of the parts on the boards are old parts and they can be found. They're available. It's just that sometimes I'm gonna come across a batch that is not very good, and so I waste money. I didn't pay a lot, but I didn't get a lot from it either. So it's a risk, and it's been frustrating a little bit. Like for example, the sound chip. Not that I don't like those sound chips, but I'd like to get them off the board. Why? Because they're very difficult to find, and the good ones are difficult to find, and nobody uses them, at least not now anyway. So So these are the reasons why it's so expensive. But then again, if you look back, back in 1990, I think this is the best reference you can do. I mean, you go back in 1990s, we bought a Commodore 64, $1,000 Canadian, which today would be like freaking like $3,000 or something. It's super insanely expensive. And so ultimately you're buying a Gen X today at the price of what a Commodore 64 cost in the second year, with probably $500 back in the day for Commodore 64. Now today's maybe $1,000, $1,200. So is it that expensive? I mean, we're paying milk like 10 times more than we paid like 20 years ago. So I think we're just used to not pay that much for technology. And when you look at it, you say, well, this is old technology. But again, it's not about the cost, it's about the value. And this is something there's nothing I can do about. People see value, they'll pay the price, they don't care. They're going to buy two. Some people bought two of them. It's like, I don't care. So this is what it is. And unfortunately, I wish I could sell this at $30 a piece, like a Raspberry Pi, although Raspberry Pi don't sell for $30 anymore. So maybe people will kind of reconsider at that point. So in the end, what's going to happen from today? This is the 4th anniversary. Like I said early on, I think I've designed a lot of stuff. Some were successful, some not so much. I've learned a lot. I think Motorola support for Motorola CPUs really brought a lot of people in, but it's a very, very niche community still. It's a very great community. I'm very proud of it. Like I said, no garbage, no bullshit in this place. It's really nice. But it's as long as I cannot produce these in more quantity or bigger quantity, because my machinery is stuck somewhere, I'm kind of limited. So which kind of begs the question, do I keep going with this? So this will be a question I will have to answer. I'm not saying that I'm shutting down tomorrow. That's not what I'm saying. I'm not stopping. I'm just saying that eventually I will have to come to terms that maybe either I find a different world to get these people, to get these products out, maybe in academics or learning how to program on computers, stuff like this, which seems to be the most reasonable place to be. Or I ultimately just finish everything and then, when everybody gets their products and everything, and I'll just make it open source for everybody and I'll move on. But I have to admit that today is the upcoming months will be months of, because I kind of created and kind of completed everything I wanted to do. A final note, which is not about the future, but it's about the future, but not so much about the whole product in general. There's something that will be possible with the Gen X that I forgot to mention, that it was designed to have two separate CPUs, but ultimately it's been designed in a way that could be working together. So that could be something interesting to look after after a while, where you could have you have to share the resources in between the two. So a note like this. But yeah, so the plan really in the future, in the short, there's no plan for new products. These are the products I decided to focus on, finish them, complete them, try to get more people in the fold, and try to create more contents for them. And yeah, that's what's going to be. I don't see myself creating anything new, because one of the problems I've been having as well is getting myself into development hell. And I stay in development hell and it just stops everything else. And I need to get out of there. So if anything comes out that would be new, it would be a subset of what's already been created, and there's nothing else to do than just respin it in a certain way and be done with it. So is there anything else? And I think the world as well has changed people's mentality about things, or changed people. It's really affecting what's going on in the world. So people are not so much into it anymore. So I don't know. Yeah, that's it. So I think I really went around. Finally, we have a raffle for the Gen X pizza box. There's the QR code. You can go see Michael. I think it's finished. I think you're done, right? For the exhibit today. But you can go and scan it on YouTube, I suppose.
Okay.
Say that again, Jeffrey?
Yes. The exhibits are done for today.
Okay. So
they start up again tomorrow. But yes, QR codes on all of them.
Yeah, there's a QR code to go on Discord if you want to join the community, at least to come and peruse and see stuff. And I want to say thank you for Jeffrey again. to invite me again and the community at VCF for bringing me in again. So if there's any questions, I'm here. If there's still people in the room.
There's still people in the room.
Thank you for staying that long, sticking with it.
Anybody have any questions? Do you want to either come up here or do you want me to repeat it? Okay, so I'm going to repeat it for you. Go ahead. The graphic subsystem, is there an accelerator of some sort? Like a blitter?
Well, the VK2, the chip I designed, I mean, which I talked about yesterday in presentation, if you want to know more about it. You know, there's like I said, bitmaps, sprites, tiles, different layers. It's very complete for 2D kind of pixel art style. I like graphical style of the 80s and 90s. There's the Dma Controller. The Dma Controller right now does some stuff. It's not as powerful as the Amiga Blitter at this point. There's still a lot of functionality to be implemented in it that would make it more like a Blitter. But at the same time, I don't have the restriction that Amiga had at the time. But on the other hand as well, the 68000 was very easy to steal cycles and do transfer while the 68000 was doing a lot of stuff. So as an example, the 68 SEC00 doesn't have 7 clock cycle in between every fetch. There's only 3 and there's no stealing to be done on any processor from that point on. So, is there an acceleration? It is an acceleration in a way, if you will, but there's, in terms of making it like a Blitter, it will come in the future when I have more time to finish these things, because my strategy was, let's design a chip, let's make it work, let's get it out there. And what happens is that some people are starting to use it, and people are saying, oh, it'd be nice to have this or have that. And I've talked about this yesterday as well. The line I have to draw where I could stuff it with a lot of features and most people don't use them. The sound chips is a good example of that. They're there, nobody uses them because they're complex to be used and everything. And, you know, so the graphical stuff is the same. So I will enhance the code when there's a need to enhance the code to make it better. And so far, there's no need. But it's in the plan for VK3 implementation, which is still in its infancy, to make the DMA and make it more like a Blitter type of thing. But in the system, there's a lot of memory for the VRAM. There's a lot of system for the graphical memory, which the Amiga, for example, didn't have. They were sharing the same memory. In my case, I don't have to do this. So there's plus and good side and bad side about this. Does it answer the question? Because it's kind of a tricky one. Yes? Okay, cool.
She says she could put Out of This World onto it. It's a game.
Yeah, but again, if somebody had a project to do something like that, they would need something specific to really make that port or something, I would be more than open to help to make it happen. I really want to be more on the you need something, I will help you create it, as opposed to I'm going to stuff it with stuff that nobody will use. You know, that's most engineers' problem. You know, we just, what's the expression for this is the thing that engineers just put more feature creeps.
Feature creep, yes.
Yeah, so I stopped doing that a few years ago, and I'm like, I bring it to a level, and then from that level. So if anybody has plans to do certain things, I'll be more than happy to help to make it more. But there's a part of the work that people needs to do to come to that point for me to, okay, I'll do it. I'll help you out for this. Because there's a lot of people who want stuff, but they don't do anything. So, oh, yeah, I want this, I want that. Yeah. It's, again, sorry.
So you say you want Blitter? Is that what you're asking?
Yeah, two things. One is the Blitter.
She wants Blitter.
And second is a vertical scaler.
And a vertical scaler. This is from Burger Becky. She wants Blitter and vertical scaler.
Oh my God, she's so tough with me. Scaler, I don't know, but well, we can talk about it.
Okay.
Does that guarantee she'll do something? She'll do it? Well, she need to do it to a point.
Wolfenstein 3D. She wants to do Wolfenstein 3D. And that's her request, to do those two things, and she'll do Wolfenstein 3D.
On which one? On the Gen X or the one of the 20 on the which processor you would use?
65616.
816?
I did it already.
She did the Apple II GS version already.
Ooh, sweet.
Stay 3D and out of this world. She already did it.
Wow, I'm impressed.
Yeah.
Okay, no, we can talk. I mean, like I said, I
Yeah.
mean, it's you know, it's like a Doom. You could do a Doom on the
Yeah.
6840. It's pretty straightforward, although they would still need like some mathematics, floating point stuff or whatever that would be needed to be implemented. It's something I wanted to do. So
Multiply, divide, and vertical scalar.
you mean float or fixed?
Fixed.
Oh, there's already the full math. There's a floating unit in the FPGA that does all the multiplication, division, and everything in float. And there's the fixed point that does multiplication and division in unsigned and signed.
Quake needs float, Doom needs fixed.
Oh, there you go. I have all of it. The scalar I don't have. Everything else is there. So let's talk.
Yeah.
I mean, you came on the Discord, so you're on Discord now. So let's have a discussion.
Yeah.
But again,
That'd be good. She can make the software.
awesome.
Any other questions? Looks like that's it.
That's it.
That's
Come on,
it.
guys. Not
Wait,
even on
wait,
YouTube or
hold on.
something.
Let
No?
me see on YouTube. Yep, there was one on YouTube. Let me go back. This one, hold on. This one is a little bit like
Tricky.
hold on. All right, so this is what I was. I'll read it verbatim. Why would someone buy one of your designs versus a Mega 65 or Commander F16 or some other retro computer?
Oh my God, the ultimate question. Why did
Yes.
you buy my thing?
Yes,
Oh.
you're gonna sell me your system. What makes yours so great?
Well, it depends on who wants to buy. What do you want to achieve? You know, if you're buying a Mega 65, and I don't mean to be disrespectful or anything, I mean, Mega 65 really came in the market with a good idea, which is, hey, here's a beautiful computer that was supposed to be, and we replicated it, and we use an FPGA to do it, and you have the chance. It's the same, looks the same, almost the same. But at the entry level, if you don't know anything about the the C65, which most people don't, I mean, everybody doesn't know anything about the C65, you can start with a C64. And it just happened that the design, the base of the design of Mega 65, and again, I really want to quote on, I'm not being disrespectful or spiteful or anything, but it's ultimately an FPGA board, the same way Mr. is. That's the angle they decided to go, and I'm not, again, not bashing about it, not judging. There's already videos about how to transfer your stuff from Mr. to Mega 65, which is all good and dandy, if you will. It's a beautiful machine. People working on it's all great. So, but it just addressed, it's a user, I would say this is a user / a little bit developer machine. The X16 is a different beast altogether, because I was really looking forward to the X16 to come out. Not that I saw as a competitor, because I don't think we're competitor, but I saw it as a way to get people more interested into doing new retro stuff, really got involved. Now the emulator is out. People have been doing a lot. Well, I mean, it's been out for a while. They've been doing a lot of stuff on emulator, but then it's the future is uncertain. So what kind of work you want to do? That's the ultimate question. What are you interested in? If you want to play, then the Mega 65 is definitely the computer to go with. If you want, like right now, you're spending €1,000 to buy a machine you want to play, that's the machine you're going to buy. If you want to play with new stuff, but you don't want to spend a fortune, then the X16 is your computer. I mean, there's a great, huge community, but right now they're just developing on an emulator, and we don't know what's going to happen. And the management of that project has been like, again, I don't mean to be disrespectful, but you know, it's been on and off, and it's not clear, and it's been difficult. I think back in the day when I did talk to David and we'd have joined forces, I think it would have been a crazy machine and everything, but we had differences of ideas. So why buy my machine? Because you want to have fun developing on new hardware, and it's not cheap hardware. It's not a 6502s. It's definitely a high-end type machine, and that's it. So because if you compare my pricing to, if you just calculate money just for money, my machines are expensive as a Mega 65, but they're very kind of locked into what they're supposed to be. It's not going to be it cannot be a Mr. Board. It's really about experiencing. I'm trying to sell an experience more than just a box with plastic and parts. Because if I could have put just an FPGA in the middle and say, I'm going to include everything in FPGA and make my life easy. And the Foenix is everything but easy. But that's I would say the more human side of things. It's really more about what you get out of it as just spending money and transferring software and make it run. So that's why you would go with my machine, because you're prepared to do stuff that you wouldn't do on the others, and you're going to reap the rewards. So that's how I would present it. Does it make sense?
Yeah, makes sense to me. You know, the simple answer is it depends on what you want to do with it.
Yeah, it's like trying to sell you a treadmill. I'm going to sell you a piece of equipment that you probably won't use, but you'll be happy to think that if you buy it, you might lose some weight, and you'll be proud of you when you do. But at the end of the day, you still need to do the work, right? So the Foenix's products are exactly the same. You need to do the work. If you don't do the work, you got a big expenditure on your ledger, and that's all you have.
Yeah. All right, I have another question on YouTube. Any chance that the graphics chip can support Overscan so games can look like arcade hardware on a CRT as opposed to the big borders home computers usually have? Something like 384 by 224.
Well, right now we are supporting the the resolution we're supporting right now are, like I said, from, to be able to interface to a monitor, a normal monitor from today's, right? So the basic VGA 640 by 480, like I mentioned before, we're doing the 640 at 400. Now it's 70 hertz. And we have the 800 by 600. This is the graphical side. And we have 1024 by 768 for the text modes. So we have very tiny characters on the other side. Now, on the graphical side, you can double up the pixels, okay, which means that you divide the resolution by 4, okay? So you end up 320 by 240, 320 by 200, and 400 by 300. So the pixel is 4 times as big. The way I interpret his question is that, could I do anything else than that? The answer is no. But could I do could I have a look like an interlace system? To a certain degree, yes. Like you have a line of pixel and there's nothing, and a line of pixels and a line of nothing and a line of pixel. Yeah, I could do this. It's rather simple, because since the logic is just doubling on everything, it's just turning off the vertical doubling, and you just have the same kind of feel, if you will. So yes and no. So can we have bigger resolution, like big pixel resolution on the normal monitor? Yes. Would it be like an interlace system? No. But is it possible? Yes. But does that make the difference between you spending $1,000 for it and to buy it? I doubt it. I'm saying that because people ask me a lot of different things that are not specifically on the system, thinking that if it was there, they would make a move and get it. But I don't think it's enough to justify spending $1,000 for a system. But yeah, it's possible to be made. Again, it's really out of the necessity and the need of getting something done. So is it possible? Yes. Is it there? No. But can we do big pixel? Yes.
Okay, any more questions from the audience?
The last one? No, come on.
No, there's a comment. 15 kilohertz monitor support would be great. If someone says they're interested in doing game development, but
Yeah. What monitor they would be driving? What monitors does 15K nowadays aside of a CRT?
Yeah. Which one? Arcade CRTs. I guess arcade machines.
Okay, so you know what? I'm going to say something about this. Okay, there was a time, and I thought about using the Gen X board as an arcade game board. Okay, and this is a very specific niche place it could be. So you could literally use a Gen X, do a development, and if it was the case where that board could be used in the arcade games, well, at that point we could cost reduce it and make it more available for that specific purpose. Then yes, I could do the 15K. I'm not saying it's impossible, just that my target audience right now are using normal monitors. I understand very well that if you want 15K, I could reduce the frequency by 2. So can I achieve it with the hardware we have? Yes, absolutely. Is there a use case aside of arcades? No. But if there was a use case for arcade, yes, of course. And I thought about doing a board, just the bare board, just everything, all the graphic possibilities. You could have crashing an amazing game with it. And if you want to have 15 kilohertz, we could adapt it for that specific purpose. So in that sense, in that context, yes, we could do all that. Is it possible to do it now? Yes, if it was, like I said, a use case and people serious about doing something else, yes, I'll put the time. I'm not going to put times in somebody's wishes. Oh, I wish it was be there. It needs to be serious. And when it's serious, then I'll do the work and you'll get what you want.
A comment. I saw your prototype today at VCF and I was seriously impressed by the Amiga 600S case. Really pretty and the dual CPU capabilities. Fascinating. I want one.
You need to get the wife to sign off on it. That's the
yes.
You'll need to do a lot of dishes, my friend.
Yes. One more thing, I don't know what it means, is VHDL. I thought only Canadians and Europeans use VHDL.
I don't use VHDL, I use Verilog.
All right.
VHDL is too verbose. There's too much syntax for nothing. It's just blah, 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 blah.
Someone said 360 by 230 is a perfect NTSC overscan size.
Well, I wouldn't know that in that case, like I said, if it becomes a non-standard product, then we could readjust and have the right frequency to make it happen with that frequency. I don't know specifically what's the crystal, the original crystal to generate that. But again, if it's a special case, a special product that goes, I would customize it to make it work for that world, if you will. And definitely something I'm definitely interested in.
All right, looks like that's it for the comments and questions. I think your time is up.
My time is up, seriously?
Yes.
Aww.
Yes. All right, but it's great having you back again, and I hope this supports what you're doing. That's part of what we do here.
Yeah, thank you so much.
Hope more people are happy because of it.
Yeah, I hope so. I mean, it's a tough crowd, the retro community is a very encapsulated crowd with certain ideas, and there's a lot of cults. And transcend those cults is I can go and pick some out of these cults sometimes, and it's cool. But otherwise, that's why I was saying that the X16 could make eventually a big difference, because the crowd is so big and they had, at least for a while, a lot of attention. They could have helped us in a way by bringing more people to go back to the idea of creating a new retro computers. We'll see. It's kind of sad a little bit, but anyway. Thank you very much, Jeffrey. Everybody in the crowd and everybody remotely, thank you for watching. I'm really grateful. Hopefully, if there's any questions I can answer, come on Discord and I'll answer it, or the community in itself. Jeffrey, good luck. I hope it was a great day, better than yesterday.
Oh yes, today was better than yesterday. Good, very good.
Yeah, I watched a little bit the whole Commodore crowd talking. They seem to have a lot of fun together. So yeah, I'm super happy for you, and I guess we'll talk soon.
All right, thank you, Stefany.
Thanks everybody. Thanks, Jeffrey.